Afternoon all, this is Vishal Singhal from SalesChat. Today we have Mr. Takuma Kimura from Japan, Hosei University, Japan to be precise, also our intern at SalesChat AI Lab. He is presenting us sentiment analysis on product reviews by using Lemmatization and tf-idf. So this session is being recorded, so you can start sending questions as and when you have. We'll try to answer all of them towards the end of the webinar, but unless they're slide critical. Uh, and this is a good time to ask him any questions. So transferring your call, the presentation to Takuma. Go ahead.
Okay. Okay. Good afternoon, everyone. I'm Takuma Kimura from Tokyo, and intern of SalesStart. Thank you for the opportunity to present my intern project today, which is titled Sentiment Analysis on Product Review. I have engaged in empirical research in business administration using statistical analysis and qualitative studies like interview analysis. However, as for qualitative analysis, I have only carried out manual analysis. I mean, analysis by human hand. So I have studied machine learning in this course to analyze text data. This presentation is a part of my study outcome. So what is sentiment analysis? This presentation is titled Product Review. We can see many product reviews on EC sites such as Amazon.com. And sentiment analysis is a good analysis technique to analyze such a review site. Today, business firms can obtain much text data such as records of product reviews and other review sites. Customer reviews not only consist of words and phrases, but also contains emotions of customers. Emotions reflect the attitude of customers. That is, it reflects whether their emotions are positive or negative. Analyzing these underlying emotions in text data is important and can be carried out by using sentiment analysis. Sentiment analysis can be defined as a process of extracting and understanding the sentiments defined in text documents. It is a text classification technique that analyzes a message and identifies the underlying sentiment. So now let me talk about the practical importance of sentiment analysis. As a method of marketing analysis, we can regard the sentiment analysis as important by the following reasons. First, sentiment analysis enables us to understand the underlying emotions of product reviews, which enables us to predict the customer's future purchasing. Second, product reviews are qualitative data and thus difficult to be analyzed. But the sentiment analysis converts product reviews to quantitative data, and thus makes it easy to be analyzed. Finally, if we build an appropriate machine learning model, sentiment analysis can gain insight from unstructured text data very efficiently, and thus can provide us with real-time data. Application of machine learning to sentiment analysis. Language data such as emails, social media, product reviews, and customer interviews contain rich information. However, it is unstructured, so it is difficult for us to analyze such data and gain insight from such data. And it is estimated that about 80% of the world's data is unstructured data, including language data. So whether we can gain insights from such data can be a source of competitive advantage in the business world. However, analyzing the underlying patterns in unstructured data is difficult and tremendously time-consuming. So practitioners have applied machine learning techniques to take text analysis like sentiment analysis. Sentiment analysis and text classification. In machine learning use of the term, some types of sentiment analysis can be regarded as text classification. Sentiment analysis is a supervised learning problem that tries to predict emotions in the text. Application of machine learning to sentiment analysis provides us with the following benefits. First, machine learning can analyze a huge amount of data in a very short time. Without machine learning, we have to sort thousands of customer reviews and spend our whole life to sentiment analysis. Second, due to its computation speed, machine learning can provide us with insights from the data in real time. It can solve one of the problems of sentiment analysis that even a short time delay in dealing with the customer reaction can result in customer churn and the spread of bad reputation. Finally, machine learning can increase the objectivity of the sentiment analysis. Many previous research revealed that people only agree around 60 to 65% of the time when determining the sentiment of a particular text. So, for example, we discussed the product review and what sentiment is expressed in this review. We discussed. So, in such case, we can only about 65% agreement. So we can use the results of sentiment analysis as good reference points with a certain level of objectivity if the model achieves 70% or more. Approaches for sentiment analysis. NLP stands for natural language processing. Sentiment analysis uses various types of natural language processing algorithms. The main types are rule-based, automatic, and hybrid. Rule-based approach relied on a set of manually crafted rules such as stemming, tokenization, and lemmatization that will be discussed later. Automatic approach relies on machine learning techniques where we build a classification model by learning from training data and make a prediction of sentiment by using the model. Automatic approach uses supervised learning algorithms like naive Bayes and support vector machine, and so on. Hybrid approach is a combined use of rule-based and automatic approach. In general, a hybrid approach will be an effective and efficient approach in text classification type of sentiment analysis. Let me introduce NLTK, which is a natural language toolkit. NLTK stands for Natural Language Toolkit, which is a set of libraries and programs for symbolic and statistical NLP for English, written in Python. This project uses NLTK for tokenization and lemmatizing. Next, let me talk about tokenization. Tokenization is a process of splitting a text into smaller units. This smaller units is called tokens. By splitting the text into smaller parts, tokenization makes it easier for a learning model to understand the pattern in the text. Tokens can be various levels of units, such as sentences, words, numbers, characters, and symbols. So we can apply tokenization by both sentence level and word level. Now let's see an example. Here, I'd like to show an example sentence. I will tokenize a text. I was born in Japan on September 6th, and it is also my friend's birthday. First, I tokenize this text by sentences using NLTK.sendTokenize, which splits the text into two sentences, this one and this one. I was born in Japan on September 6th, and it is also my friend's birthday. Next, I tokenize the text by word using annual decay word tokenize, which splits the whole text into 16 words here, such as I was born in, etc. So we can tokenize same sentence in various levels. Let me introduce the construct of token normalization. Token normalization means canonicalization of tokens so that tokens will match irrespective of the superficial difference in their character sentences. Canonicalization is a term of computer science, which means a process for converting data that has more than one possible representation into a standard normal form. We human beings can easily understand that, and dogs and this is dog, only dog. A dog and dogs have the same meaning. The difference is the number, one dog, or two or three or four dogs. However, a computer can be easily confused with such superficial difference in the world. Moreover, it is difficult for a computer to understand that and is have the same meaning because these words seem to be completely different by their spelling. A and M and I and S, very different. To make some of the words more understandable for a computer, we need to transform them into a standard or a normal form. That is the purpose of token normalization. And there are two popular ways to doing it. Those are stemming and lemmatization. First, let me introduce stemming. Stemming can result token normalization by chopping off the suffix of a word. For example, the word play in a third-person singular form becomes plays. In this case, the last character, S, is suffix, and thus it is removed. Stemming transform plays into play, the base form of the word. That is a dictionary form. In the case of past tense, it becomes played, and the suffix is ed. Then stemming removed ed and transformed the word into play, the base form. Similarly, in the present progressive form, it becomes playing, and the suffix is ing, and it will be removed. And then playing become to play by stemming. However, in some cases, stemming generates a strange form. For example, stemming the word study. Study is studies in the third person form. If we apply stemming to this word, the suffix is es, and es will be removed, and then the word study, S-2-U-D-I, a strange form. Because stemming just chop off the suffix without considering the change in the person or tense. So study changed their spelling with the es and ed and ing. So stemming sometimes make some word to strange form like this. So stemming is a simple way of token canonicalization, token normalization, but it has some weaknesses. The first thing I said about the said the slide before. So other point I'd like to discuss here. First, the stemming can lose the meaning of the word. For example, in the case of the word so, she saw, yeah, so, stemming regards a and w as the word suffix. So the stemming removes a and w, and then so becomes just s. Of course, s has not a word, so by stemming, the so loses its original meaning. Second, in some cases, stemming transforms words with a different meaning into the same root word. For example, universal, university, and universe, different words and have different meaning, you know. But when we apply stemming to these words, here universal suffixes al, university, ity, and universe s is suffix. So if we apply stemming to these words, all of them will be transformed into the same root word, universe. Thus, stemming make it impossible for a computer to distinguish these three different words. Computer read them as universe, as the same words. So lemmatization I recommend here. It is another way of token canonicalization because lemmatization can solve these problems. So next, let's go on to the lemmatization. Instead of just chopping off the part of the word, lemmatization transforms the word into a base form, that is, its dictionary form. Unlike stemming, lemmatization transforms the inflected words into an actual word of a language. So it can keep the meaning of inflected words and the semantic difference between superficially similar words. Since the lemmatization is more complicated than stemming, so it requires a lot more knowledge about the structure of a language. However, fortunately, if we are dealing with English text data, we can use lemmatization easily by using NLTK libraries, WordNet Lemmatizer. Let's look at an example of a lemmatization.
Question, Takuma.
Yeah.
Please go to the previous slide.
Okay, please.
Go to the previous slide, please. Yeah. So somebody is asking, shouldn't universal stem to universe or university to universe?
Mm-hmm. Yeah, using stemming, using stemming. Mm.
Yeah, so shouldn't it be converted from university to universe? UNIVERS.
In stemming, just chop off the last part of the word. So
Correct.
yeah, so in these cases, stemming regard al and ty and se as a suffix, so it becomes universe. So the computer cannot distinguish these three words. But the lemmatization can distinguish these three words as different words.
Somebody is saying it should be UNIVERS only.
Only on this one. In stemming have some rules for chopping off the words, so it depends on the each word. And this case, so the stemming package regard AW as a suffix. So it's probable that we can set some some setting, but it's default. By default, it's regarded AW as suffix. So if we apply stemming to so, the word so, it becomes just S. So the word of the meaning of the word loses.
Depends on the dictionary for stemming.
Yes, it's a ordinary package stemming tool.
Okay. Okay.
So
Go ahead.
yeah, okay. So let me talk about the lemmatization example. This is the sentence I said before. I was born in Japan September 6th, and it is also my friend's birthday. Here, I canonicalize this sentence by using stemming and lemmatization. Stemming, in stemming, there are various some types of stemming method, but here I use the porter stemmer method. Is because it is the most popular one. When we apply porter stemmer to the sentence, it becomes like this. So was become wa, and September becomes September. Other words, we can see other words are stemmed appropriately, but it is computer, not us, to read this sentence by sentiment analysis. So it is a problem because was becomes wa. It is problem because it is not clear whether this is was or way. And September lost its original meaning, September. On the other hand, we can apply lemmatization using WordNet Lemmatizer. Here you apply WordNet Lemmatizer to this sentence. It becomes like this. You can see was become be, and is also be. That is, all of the words in the original sentence are transformed into a dictionary form. The inflected words are transformed into the base form, irrespective of the form in the original sentence. So the word was and is in the original sentence were transformed to be, the base form. And you can see September keeps September, keep its original form. So it doesn't lose its meaning. And one more thing, in general, text data contains many words which are very common in various sentences and have a little semantic content. Examples of these words are the, an, to, and so on. These words are necessary in grammar, but these words have a little semantic content. These words are called stop words and will be removed in the pre-processing of natural language data in order to make the language processing effective and efficient. By making a list of stop words, we can exclude them in the subsequent text analysis. This project uses existing stop word list, English, existing tool. Is a list, existing list. And one more thing we should pay attention to. In NLP, the text will be converted into a form which can be easily calculated. The text will be converted into a vector. Generally, the text will be vectorized based on the number of occurrence of each word in the text. How many words we can see in the text. In this transformation, frequently used words are regarded as representative and have important meaning in the text. However, irrespective of their importance, some words are frequently used in all texts, and other words are not so frequently used. For example, we use the word AI, artificial intelligence, many times every day. Even if we count how many times we use artificial intelligence in our articles and presentations, we cannot understand what the main topic of each articles and each presentation, because most of our articles and presentations use the word artificial intelligence frequently. To solve this problem, we can use sklearn tf-idf vectorizer from sklearn. This uses the tf-idf score to vectorize the text to consider the relative importance of the words. We can use the tf-idf vectorizer using this import snippet. So what is tf-idf score? tf-idf stands for term frequency and inverse document frequency. tf-idf score measures the relative importance of every word in the corpus. It will be high for words which are used frequently only in a document, but not in other documents. And the score will be low for words which are used frequently in most of the documents. tf-idf score is calculated by term frequency and inverse document frequency. Term frequency represents how frequently a word is used in a document. And inverse document frequency represents the ratio of documents containing the word. tf-idf score is the multiplication of term frequency and inverse document frequency. And as we can see in the formula, when the word frequently occurs in a document, the tf-idf score is high. But a word is used in many documents, the inverse document frequency will be low. And so the tf-idf score will be low. So we can consider both a term frequency and the term frequency in the document and term frequency in other documents. So let me talk about the problem statement here. This presentation is about the sentiment analysis on customer product review. So we want to predict whether a user, a customer, recommend our product or not recommend by using a product review text data. We can regard this problem as a sentiment analysis by supervised machine learning. Therefore, we will use NLP and classification techniques to build a model. The dataset used in this study is women's e-commerce clothing reviews, which is an open source product review dataset, which can be retrieved from the Kaggle website. The raw data contains 23,486 observations and 10 features. The target variable is a recommended indicator, which is a binary variable stating whether the customer recommends the product, where 1 is recommend and 0 is not recommend. And 19,314 of the observations are recommend, and 4,172 are not recommend. So the dataset can be regarded as an imbalanced data. I mean, a dataset that has one class with the low proportions compared to the other classes. The dataset columns are listed here. The data analysis follows the ordinary machine learning process. In the data pre-processing process, NLP techniques will be applied. That is, tokenization, lemmatization, removal of stop words, and tf-idf vectorization. Besides, since the data set is imbalanced, the classifier algorithm may not effectively learn the minority class. So smooth ENN will be applied to rebalance the data. And here I use the logistic regression and these three models. For model evaluation, accuracy and specificity and AUC score will be used. I will discuss these from now. First, classification methods. As classification methods, I use these four methods based on the literature review. Logistic regression is the most popular method for binary classification, and data scientists use this model as a base model. So I use it here. Naive-Bayes and support vector machine are the most popular methods in sentiment analysis, and showed good results in previous studies. And recent studies have applied XGBoost sentiment analysis. So I included in this project.
Hi, Takuma, can you please go back to the previous slide, please?
I'm sorry. Go back.
Yeah. So, gentlemen, please ask the question. Your question is not previous to this one.
This one.
Yeah. No, the
Yeah.
next one.
The next one. Yes.
Yeah. So they're trying to read something. Any questions on this slide, please? Okay. You can go ahead. So they wanted to see something.
Oh,
Go
okay.
ahead. Thanks.
Yes. So let me talk about performance metrics I used here. In classification problems, accuracy is the most widely used and easily understandable performance metrics. Accuracy represents a ratio of correctly predicted observation to the total observations, like this. It is calculated by dividing the sum of the number of true positives and true negatives by the number of total observations. Here in this problem, true positive means the users predicted as recommend and actually recommend. And true negative, on the other hand, represent the users predicted as not recommend and actually not recommend. However, accuracy does not guarantee the excellence of the model. When we use an imbalanced data like the current dataset, we can easily achieve a high level of accuracy by just labeling all observations as majority class. Besides, more importantly, here, a negative means a user who will not recommend our products. And therefore, we want to identify negatives in order to find out what kinds of problems exist in our product. So here, the metric called specificity is important. Specificity is the ratio of correctly predicted negatives, true negatives, to the total number of actual negatives. It can be calculated by dividing the number of true negatives by the sum of the true negatives and false positives. And this is a fictitious example. So before going on to another performance metric, AUC score, let me talk about true positive rate and false positive rate. True positive rate is called TPR, and the false positive rate called FPR. In classification problems, we want to predict positive cases as positive, and we want to predict negative cases as negatives, of course. In other words, we want to achieve a high level of true positive rate and a low level of false positive rate. However, there is a trade-off between these two rates, FPR and TPR. To understand this trade-off, let me talk about estimated probability and a threshold. In classification methods, we classify the samples based on the estimated probability, which indicates the probability of a sample to be classified as positive. By default, the threshold is set to 0.5. So if the classifier estimated the probability equals to or higher than 0.5, the sample would be classified as positive. And below, the samples will be classified as negative. So this red ball is actual positive. The blue ball is actual negative. But these are above the threshold, so they will be predicted as positive. Similarly, these balls are predicted as negative, irrespective of this one is actually positive. So on next slide, if we the default threshold is here 0.5. If we raise the threshold, it becomes more difficult for a sample to be classified as positive, and it becomes easier to be classified as negative. So by setting the threshold higher, we can decrease the false positive, and it can increase the false negative. That is the trade-off between false positive rate and false negative rate. Let's look at this example. In this example, if we set the threshold as default 0.5, the TPR is 0.67 and FPR is 0.4. If we raise the threshold here 0.6, the FPR decreases to 0.2, but the TPR also decreases to 0.6. On the other hand, if we lower the threshold to 0.4, the TPR increases to 1.0, but the FPR also increases to 0.6. So we can see the trade-off between TPR and FPR exists. So a good model is a model that can achieve both high TPR and low FPR as much as possible. So considering the trade-off between TPR and FPR, we can create a performance metric with a balanced view. That is the AUC score. AUC stands for area under the curve. An ROC curve, I mean a receiver operating characteristic curve, is a graphical plot that plots the TPR against the FPR at the various level of classification threshold. AUC score represents the entire two-dimensional area underneath the ROC curve, this part. So it can be high when TPR is high and FPR is low. Thus, the higher the AUC score, the better the model is. Let's look at the results of the analysis. As you can see, as for the accuracy, XGBoost achieved the highest level, 79%. I show training accuracy and text accuracy. And the XGBoost achieved the highest level. But every classifier shows 70% plus accuracy. So the percentage is moderate, not so high. However, in general, the accuracy level tends to be moderate in text classification. And as I said before, if we discuss what the emotion is contained in a text, we can achieve only about 65% of agreement rates, human discussion. So compared to our subjective human discussion, human evaluation, the accuracy levels are fairly high, and thus they provide us with reference points that we can use to evaluate the emotions of each customer review. So the accuracy level is not so excellent, but it's very good, I think. Let's go to the specificity. As for specificity and AUC score, support vector machine achieved the highest score. Here again, not so excellent score, but the support vector machine achieved the highest. Since specificity is important in this kind of business problems, I said before, so we can say that the support vector machine works better than other classifiers in this project. Let me summarize this project. This project carried out a sentiment analysis of product review data using popular NLP techniques such as stemming, tokenization, lemmatization, and tf-idf vectorization. And it applied classification algorithms that are popular and have been found to perform well in sentiment analysis. For our business objective, specificity is the most important metric in this project, and support vector machine achieved the highest specificity. And support vector machine also achieved the highest AUC score. So these results are consistent with the previous research that showed the relative excellence of support vector machine in sentiment analysis. The methods used in this project can be applied to other problems such as multi-class sentiment analysis and multi-class text classification and only text classification. I used this same method to article classification before, and it succeeded in classify many articles. And sentiment analysis can be applied to various business fields, such as human resource management, where we can analyze employee motivation survey in a text form. This is just an example. That's all for my presentation. Thank you very much.
Hi audience, if you have any questions now, you can ask. Thank you, Takuma, for the presentation. I have some questions coming. I'll be taking them one by one. One question is, can deep learning be applied and how do they fare? Sir, can you please elaborate your question? Applied for what? And can deep learning be applied for NLP, for text classification?
NLP for text classification. I'm sorry.
For text classification or sentiment analysis, etc. Can deep learning be applied?
Can be applied to other example. You ask other example, real example.
Okay, I'll let him elaborate the question. Another one is, can you go back to classification slide where different techniques were mentioned?
This one. You mean this one?
More, go to other one. This is the one you are talking about, sir? The previous one.
This one? This one, okay?
Go a step back. The previous one.
Okay. Previous one.
No, the where the categories of where the categories came.
Categories. This one?
Sir, you tell me the name of the slide you are talking about, because otherwise we'll be going back and forth.
About
Well,
this one. Okay.
meanwhile, I'll ask another question. He's not able to name the slide. Uh, how does tf-idf compare to word2vec or BERT for sentiment analysis? Or how is tf-idf better?
Hmm. Okay. tf-idf. Sorry. Because this vectorizer pay attention to the relative importance of the words. So in our society, some words are always frequently used. So, for example, this slide, relative and consideration is used in many texts. So, if we do not use this vectorizer, the machine and the computer regard consideration and relative as important because these words frequently emerge in this text. But this consideration relative is just a popular words. So these words are used in every article, every presentation. On the other hand, tf-idf may not be used in many presentations in social science field and politics and international politics articles. So tf-idf is important in this presentation and many often used in this presentation only. But this tf-idf is not used in other articles in New York Times. So we can a computer read the text and understand its content. The relative importance is very important. So here the consideration and the relative do not represent the meaning of the text, but the tf-idf represent the meaning of the whole text. So in this case, tf-idf is used smaller times than consideration, but the importance is greater in tf-idfs. So tf-idf improve this problem by comparing the term frequency in this text and term frequency in other text. So we can regard the term tf-idf, this word is important relatively in this document compared to other documents. So, so if we do not apply tf-idf vectorizer, the computer regard the importance and the word as important word and represents this article. So the computer cannot understand. This presentation is about tf-idf and sentiment analysis.
Okay, can you go forward from this slide? The gentleman who was asking for the slide, he will stop you when you arrive at that. Go slow. Stop. Go back.
Stop here.
Go back.
Back. Yes.
That's it. Yes.
Yes. This
Yes.
one.
This one.
Yes.
So what is the question being asked, sir? Uh, so yeah, so he just wanted to see it. Thank you. Um, have you tried ANN for building this model?
Yes, I tried new artificial artificial neural networks, but maybe it the problem my skill, but it returns not good results. So I
Okay.
omit the results of the ANN.
Okay.
But maybe deep neural network work better than I did.
Okay. Any other questions, audience? So, so people are appreciating it generally. It was very informative session. It was good session. One question is there, from the list of all columns, can you please tell on which column text processing has been applied, and after that, how all columns framed to apply supervised ML algorithms?
Mm, mhm. Uh, yes, review text is main body of this data, and this is a string variable. So this contains a review by text, and it consists of one or several sentences. So we apply vectorizer this review text, and other is age is just number, and a title is string variable and title of the review, but it's not so important. So our rating is the 1 to 5 scaled grade of the rating of the product. So and the recommended index is recommend or not. So we can use both of these variables as dependent variable. I try both of them, and for simplicity, I adopted this one in this presentation. And a positive feedback count is a positive integer documenting of the number of other customers review positive. This one is maybe important, but it's not a return the good result. So I do not use it as a dependent variable but as an independent variable. And division name is a product high-level division, and a department name and a class name. We can convert it to a dummy variable and a categorical variable. Convert it as a categorical variable. And so many omit the delete the missing data and build a model. So it contains both numerical data and text data.
So thank you, Takuma, for the presentation in the middle of crisis from Japan. I believe Tokyo is completely locked down, and
Uh,
so is the entire world, and still you are presenting it here. Thank you for the presentation, and look forward to see you in future webinars as well. Thank you
thank
all,
you.
and thank you attending from across the world. Thank you.
Thank you very much, Vivek, and thank you very much for audiences.